Hi Daniela. So to solve this problem, first thing we want to do is write our equations here. So we've got, first let's do our constraint equation, which is going to be the perimeter of this. So we're going to say 13 equals 2x plus 2h plus, and remember that the circumference of a circle is pi times the diameter, or 2 pi times the radius. So we're going to use 2 pi times the radius because we know our radius is x here. So we're going to say 2 pi times x times 1/2 because we're just looking for half of the circumference there. Okay, so that's our constraint equation. So our constraint equation essentially is 13 equals 2x plus 2h plus pi x, if we simplify. Okay, now our objective equation is going to be the equation of the area. So the area of this window is going to be 2x times h for the area of this rectangle. And then the area of the semicircle up here is going to be plus 1/2, because it's half of a circle, pi r squared, in this case pi times x squared. Okay, so our area equation, we need to get h by itself. We need to get h by itself in the constraint equation so that we can plug it into the area equation. So let's do that up here. 13 equals 2x plus 2h plus pi x. So if we subtract everything from the right, we get 13 minus 2x minus pi x equals 2h. Divide both sides by 2, and we get h equals 13 minus 2x minus pi x over 2. So let's plug that into the objective equation. A equals 2x times 13 minus 2x minus pi x over 2. We're going to plug that in for h here. Then plus 1/2 pi x squared. So now to simplify this, do you see the 2's cancel? So we're left with a equals, if we distribute, we get 13x minus 2x squared minus pi x squared plus 1/2 pi x squared. So now if we simplify further, what have we got here? A equals 13x minus pi, or minus 2x squared minus, and we've got pi x squared plus 1/2 x squared. So negative pi plus 1/2 pi is going to be negative 1/2 pi, right? Negative 1 plus 1/2. So minus 1/2 pi x squared. Okay, so now if we need to combine these two like terms with the x squared, so we can rewrite this as a equals 13x minus, and we've got x squared, factor out the x squared, and we've got 2 plus 1/2 pi, right? So do you see I just combined those like terms? They both have x squared as their unknown, and then we're left over with 2 and then 1/2 pi because I factored the negative out also. So now we should probably rewrite this as a equals 13x minus parentheses 2 plus 1/2 pi x squared. So now if we take the derivative of this, a prime is going to be 13 minus 2 plus 1/2 pi x, right? So now if we simplify by distributing here, we get a prime equals 13 minus 4 minus 2 times 1/2 is going to be 1, so minus pi x, right? And then, well, let's rewrite this. That's in a negative here. So we've got 13 plus, and we'll call this negative 4 minus pi x. That's our coefficient. So now we need to set, to find the, to maximize the area, we're going to set the area, set the derivative equal to 0, so 0 equals 13 plus negative 4 minus pi x, and if we move that over, so this, we can rewrite this as 13 minus 4 plus pi, right, x. So if we move the 4 plus pi over, 4 plus pi x equals 13. Then we divide both sides by 4 plus pi. We get x equals 13 over 4 plus pi. So that 13 over 4 plus pi is the value of x that maximizes the area. So I hope that helped. I know that's a involved problem, but that's kind of how you do it.